All right, 8.2, we're on the backside now, still Hassler with you. We're going to be talking about reflections. And to be quite honest with you, we've already really dealt with reflections. We just never called it a reflection. And so a reflection means that we are going to reflect the parabola over the x-axis. Okay, and so when we do that, we're really now going to be in this form of y equals either a plus or minus ax squared. And what I mean by the fact that we've already talked about this is the fact that if a is positive, so if I have a positive a value, my parabola opens up. And we know that. But if I have a negative a value, a negative a value means that my parabola opens down. And when my parabola opens down, this is where we use the word reflect. So instead of saying opens down, we say, oh, there was a reflection over the x-axis, is the more mathematical way of saying that. Okay. And so let's go ahead and do a couple of these examples together. And the directions say that we are going to, given the quadratic equation, we're going to describe the translation compared to the parent function. We're going to graph the function, and we're going to write the vertex. When it says describe the translation, what we really mean is describe the transformation, because not only are we going to have a shift up or down, like we discussed on the front, but you may also be reflecting your graph. Okay. And so it says given, we have y equals negative x squared plus 3. And so again, what I like to do is I like to highlight the parent function. The parent function is the y equals, and then just the x squared part. That's my parent function, which means that I have some extra pieces floating in here. I have this negative floating in here, and that's going to cause me to reflect over the x-axis. And I have this plus 3, and that plus 3 means I'm going to shift up 3 compared to the parent function. And so I just like to highlight that parent function. I like to make note of what changes are going to be made compared to that parent function before I really start getting into my graph. And so is this function a reflection compared to the parent function? Yes. And what tells me that is that negative in front of the x squared. T stands for translation, and we already said that this plus 3 here is going to shift me up 3. And so again, I just like to sketch in that original parent function. And so that original parent function is at negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And so a reflection means that I'm going to look at this x-axis as like a mirror, okay? I'm going to reflect over this mirror, this x-axis, and then I'm going to shift those points up. And so I'm going to do that one point at a time. I'm going to start with this point at negative 2, 4. Actually, I'm not going to start with that point because I don't have much room to reflect. So I'm going to start at this point right here. I'm going to reflect this over the x-axis. Right now it's 1 above the x-axis. A reflection would put it here at 1 below the x-axis. Okay, I'd put it right here. And then I have to shift up 3. 1, 2, 3 puts me at my final point. Okay. How about this vertex? Well, this vertex is on the line of reflection, which means that it's not going to change position at all. If I'm sitting right on that line of reflection, I can't reflect anywhere, but I can shift up 1, 2, 3, which puts me here. Okay. I'm going to look next at this point. Okay, I'm going to reflect that point. Again, reflecting that over the x-axis puts me down here at negative 1, and I'm going to count up 1, 2, 3. All right, let's give this a try. If I am here at 2, 4, and I reflect that, that would put me down here at -4. So somewhere, let me change my color, somewhere down here. And then I would have to go up 1, 2, 3. Put me right there. And really, because of the symmetry of a parabola, I would be at -2, -1 on the other side of the y-axis. I'm going to get a graph here. Okay. We will get to practice this some more when we work together through our practice in class. So just do your best to get these notes in. Again, we do that reflection first. A reflection means I move to the opposite side, same distance away of that x-axis, and then I'm going to count my shift. All right, let's take a look at 6. I want you to pause the video. I want you to see if you can answer parts of 6 and get a graph going, and then we will check our answer. Okay, so it looks like I have no reflection for this particular graph. The a value in front of x squared is positive. And I do have the shift down 1, which puts my new vertex at 0, -1. And so my new graph is this blue graph here. Okay, so now we're going to take a look at problem number 7 and 8. And in these problems, you are given a graph, and our job is going to be to come up with a function. And so given the graph, we're going to write a quadratic function. We're going to describe the transformation compared to the parent function, and we're going to write that vertex. Okay, and so let's see. It looks to me like this particular parabola has been reflected due to the nature that it is now upside down. So yes, there's been a reflection. And it looks to me like the vertex, which is typically at 0, 0, typically the vertex is at 0, 0, right? -1, 1, 2, 4, just getting these other parent function points in here. And so it looks like I have been shifted up 1, 2, 3, 4, 5. So I have this translation of up 5. And as a result, my parent function is typically f of x equals x squared. But because I have this reflection, I'm going to have a negative in front of my x squared. And because my vertex has been shifted up 5, I'm going to add 5 to the end of that function. And that means that my new vertex is at 0, 5. Okay, so again, I always like to get that parent function graphed to help count and compare what the new graph is doing. I like to write what my parent function is, f of x equals x squared, and then I like to apply the transformations to that parent function. All right, I want you to pause the video, try number 8, and then we will check it together. Okay, so it looks like this also was a reflection of the parent function since my graph is upside down. It also looks like compared to the parent function vertex of 0, 0, my vertex has been shifted down 3. And so I have a function that says f of x equals negative for the reflection, x squared minus 3, which is my vertex at 0, -3. Okay, so now we're going to do some practice. And if you have any questions, always feel free to ask your teacher.